Hey folks, so I just passed my second anniversary of working as a software engineer out in the industry, so I wanted to share 5 big things that I've learned or that I wish I would have known when I first started out to help you out in your career. Let's go. So the first thing we're going to talk about is something that I came up with recently that has been helping me out lately that I didn't start at the beginning of my time as a software engineer and I wish I would have, and that has been logging what bugs I solve and how I solve them. Let's talk about why a log like this is useful. In the end, you make the majority of the mistakes you're going to make in your first few years, in the first few months of working. And you're also taking in tons and tons of information, right? So we're not gonna keep super clear track of what all those different problems are. Something that feels really fresh because it was a big issue that got you stuck for days today is not gonna feel very clear, or the solution is not gonna be readily apparent to you necessarily in 4 or 5 months' time. And so that's an issue that I've started to bump into. So I came up with this idea of essentially I keep a running Google Doc, and you wanna be careful. You don't ever wanna copy source code or confidential information out of your company's environment. For me, I end up having to just kind of write out quick tags or summations of it and assume that I'll be able to search for them in the future. But if it's a personal project, you could ostensibly just take the whole error out of the log, add that into a Google Doc, so that way it's searchable in the future. But the goal here is to document what the problem was and how you fixed it. And that is just gonna be there to save you a lot of time, because we do end up bumping into the same issues in software. Sometimes things roll back around. Sometimes it's a rather cryptic error that's being served by a third-party service that then you're not sure what it is, but if you log that, it makes it much easier for you to go down the process of trying to hash out what is actually going wrong under the hood to get your project working again. It also carries a huge benefit in the perspective of making you a more independent and valuable member of your team. Because if you work on a small team or a team that's intended to scale quickly, for me, I work on a team where a lot of developers from other parts of my organization come in to learn things by building with us. So I deal with a lot of new person setup, new setup of projects, new setup of repositories, new setup of local development environments for these people. And it can be really challenging to solve some of the more cryptic issues that come up with onboarding processes or requirements or approvals, whatever it is. And so by keeping a log of what the errors are and what services are tied to those errors, it's sped up my ability to onboard somebody into a project and get them learning and save some of my time, save some of my manager's time. All those things are really valuable to my team. And so I really encourage you, just go through, make a Google Doc, add what the problem was and a couple quick tags about it, add a description of when it was experienced and kind of the underlying thing there, and then also provide some documentation or some logic on how to fix that issue. It'll save you a ton of time. It's fairly easy to do, but I can't emphasize it enough. Start it as soon as you're able to. Because for me, I started this 2 or 3 months ago. If I had started this when I first started at my job, it would have saved me dozens and dozens of work hours over the span of the last year. So that's just a thing to think about. It'll get you unstuck faster and make you more independent on your team. My second big lesson that I have learned, and this one I learned kind of the hard way in the last 2 years, is make sure you're choosing the right language or the right tool or the right system for a job, and ask other people for their input on those ideas before you start to build something out. I had an experience of trying to pull in data from a bunch of different data sources to be rendered on a dashboard on an internal site. That dashboard was on a site that had a backend in a JavaScript library called Strappy. I decided the best way to extract the data was going to be essentially grab the data out of these services, cache it locally inside our database, and pass it along to the front end. The problem was I was doing that extraction work in JavaScript, and the APIs that I was hitting are not APIs that are meant to be massively scaled, constant uptime, ready for all the data to be accessed all the time. A lot of it is kind of archival data. And so that data takes a second to wake. There's delays in the API. Sometimes it's as much as 10 seconds on certain calls and requests. And so if you've worked for a while in JavaScript, you'll know that an asynchronous language like it really make it difficult to do those kinds of time sequential calls without getting into race conditions where you're going to start to have, certain lines of code executing before others, because the JavaScript event loop, that is the underlying technology of how JavaScript schedules what actions it takes in your code, is not really cut out for those kinds of asynchronous responses coming back at different time intervals across different systems. It just makes for a big mess. And so I spent so long debugging that project. I spent probably a month building the underlying logic, and then 3 months were spent just debugging and trying to understand what was going on in these APIs and reaching out to those teams and hitting roadblocks on their ability to support our requests and getting into timing functions and timeouts and trying to narrow those down to extract the data as quickly and efficiently as possible. That in the end, it turned out, after talking to a more senior member of my team who knew more about the underlying tech that we were dealing with and also what kind of jobs now that we needed to run, who just said, you should be writing this in Java. And we ended up building out a project in Java in 2 weeks that fixed the problems I had spent 3 months trying to solve in JavaScript. And that was also with me not being an expert in Java. Granted, I had help, but by picking a language that's better equipped to those kinds of sequential calls, and by deferring to the experience of someone who knew more about that situation, I would have saved myself a lot of time. And so don't fall into the trap of just using what you know if you have a little bit of freedom about how to solve a problem. There is always a time to use what you know, to try and take what the knowledge you already have and apply it quickly and efficiently. But when you're kind of wading out into new waters, it's really good to do a little bit of due diligence on what is the right language and the right tool set for the solution that you're trying to generate, as well as talking to somebody more experienced who's going to know about some of the areas that you don't know about ahead of time and can help steer your ship towards the right set of tools and the right process. That way you don't waste a ton of time trying to do something brute force in a system that just isn't well built for it. Because the reality is a node-based JavaScript server is not a good system in general compared to other options on the market for data extraction APIs, which was essentially what I ended up building, was a Java data extraction API that still wrote data to that same database, which allowed for it to be called quickly. But the extraction piece was obfuscated into some Java code that was better equipped to do the job it had to do. And then the JavaScript that needed to do the dynamic calls was much better at pulling that data in and distributing it to the front end than a Java backend would have been. So by breaking those things out into smaller tasks and by deferring to the knowledge of somebody who knew more, I would have saved myself a ton of time. For our third idea for someone that's starting out a new career in software development or software engineering to try and help you excel and advance faster is taking some time to look under the hood of the systems that you're working in. Read some documentation, get familiar with the code base that you're working with. If you're working in React, you really should understand how React works under the hood. And I'm going to give a couple examples of things. One great example was actually in the last section of the video of data extraction and API calls were not operating in a sequential way the way I expected them to be when I first started writing them in JavaScript. And that was because I fundamentally did not understand the JavaScript event loop, which is that underlying engine that assigns the JavaScript executor to do whatever given task is at hand. Because the JavaScript event loop was essentially dumping tasks in an order that I wasn't expecting, it was very hard for me to debug that code. I ended up talking to my manager about it. He pointed me towards understanding more about how the JavaScript event loop is working under the hood, and by that knowledge has then carried me forward, not just in that particular problem, but has solved several other issues for me over the span of the last 2 years. So taking some time, understanding the underlying systems, like in React, I had another example where I was using a set timeout function to essentially to orchestrate something in a carousel. I wanted a carousel to change every 5 seconds, right? But then when I did it in React, I was having that changing behavior was starting to stack. So when it would first change and then it would change again and then it would change again, I was getting multiple timers being created for each change and I couldn't figure out what was going on. Again, I went to the documentation. I found out that React actually holds state and doesn't clear it when it's still on a dynamic page until the page is refreshed. So those old timers were still living and repeating in old versions of state and triggering a state update function. And each time the state update function was being called, the component was being re-rendered, which then caused that timeout to be created again. So I was having a new timeout being created each time it would change, which was happening increasingly quickly as the page was being refreshed over and over again. So these are the kind of examples of you almost never bump into some of these things until you do, and then suddenly it's very hard to solve these problems unless you've taken some time to understand the underlying tech behind the systems that you're working in. So take some time, look under the hood, read documentation, develop a more advanced level of technicality when you're working in these systems. We don't have to just treat everything like a black box. We can get an understanding of how some of these things work. And this all carries an added benefit, which is when you work in a system that feels very complex, it feels like something that you couldn't imagine writing, or it feels like it's the future of all software development, and it feels very big and intimidating. It feels very far away from what we do in a day-to-day. But then when you break down source code and into documentation, and you understand what's happening under the hood in one of these more complex libraries or something that's very well built, it exposes you to better written code than your own, which you might then be inspired from that code to then improve your own code, work on how you do things. Maybe it's commenting, memeization, who knows? But it also is a big psychological advantage, because then we start to understand, once you understand how a more complex library works, then it becomes easier for you to see yourself taking on a more complex challenge. It's a confidence booster, essentially, to realize that really all code is a bunch of simple systems overlapping and emerging into a much more complex entity. So when you understand that, it gets easier to build in the system. It helps you, and it helps you learn, and also just has that big psychological increase in confidence that can help you move forward in your career. So my fourth big learning is that scope creep is inevitable, and you always need to be setting boundaries with stakeholders early in a project rather than waiting and being reactive to whatever is going on. And this is something I learned over the span of taking over a couple different projects. There were small projects, internal things that I was essentially being the point engineer on. I was building the system out. I already had a backend system that was fairly customizable. If you're familiar with Strapi, you know it's fairly easy to set up new content types and things inside a Strapi system. So I was using that as kind of my backend, and then I was building out front-end experiences for different teams based on their needs. That issue with that is oftentimes scope creep is a big, ever-present force in software engineering. And so essentially I had people that were non-product, professional product owners that were setting the goals of projects and adding feature sets without an understanding of what the underlying availability of the data that was needed was, what the underlying needs of a project to build that was, like what the actual time to build a feature like that was, as well as what it takes to maintain a project like that. So going in as a new engineer, I, of course, just kind of assumed, oh, let me see what I can do. I haven't done this before, but let me give me 2 weeks. I set like a, just what seemed like a reasonable timeline to me to be able to get it done, assuming that there were no major issues along the way. But the thing is, especially early on, anytime we're doing something new, you're almost inevitably going to bump into something that's broken or doesn't work the way that you want it to, and it's going to take you longer to fix that because you haven't dealt with that situation as often. And so learning to be conservative, when you're first assessing the time and the engineering requirements of a new issue, if you haven't done something like that before, be conservative. Give yourself 2 times as much time as you need if it's a short window, or 1.5 times, whatever feels normal to you. But give yourself a little bit extra time. Give yourself buffer time for mistakes and bugs to emerge, and for you to take time to learn things along the way. Because otherwise, you're going to end up in a situation where people are breathing down your neck for a deadline. It makes you more stressed. It makes you think less clearly, and you're not going to be as good at solving those problems, and you're eventually going to deliver a worse product for it. The idea of a worse product is also one of the big risks of this issue, because when you get a worse product and you start getting into the feedback loop before you're necessarily prepared to be in a feedback loop. So like, let's say I've got 2 weeks, and then I rush to deliver that thing, and then I demo the thing to a team when it's really only half done or something along those lines. Well, now I'm going to start getting feedback from them. And so on top of building the existing stuff, I'm also fixing old things, and I'm getting caught in this feedback spiral, right? Where I'm just trying to keep up with the feedback that's being given. They expect me to be able to get lots of this done in a very short time window because I did the whole build in the first 2 weeks. So they don't understand why the change is happening. And now we're in this spiral where the scope is continuing to creep. I'm falling further and further behind, when instead what I should have done is buffered with some additional time and also set really early boundaries of, hey, I can show you where I'm at, but this isn't ready for feedback yet. I'm still in the initial build. We'll understand that. That also gets whoever you're working with into the mindset of, oh, I need to really clearly define my asks to this person before I come to them and just say, add this, this, and this in a casual meeting without any definition of what that's going to look like, how it's going to operate, where the data is going to come from. You give them more time to define and clarify their expectations and ideas instead of waiting for them to just give you feedback and then just go through iteration forever until people conclude and kind of come down to the final definition of done of what they want out of a given story or task or whatever you're working on. For our 5th tip of this video on how to actually improve in your first early years as a software engineer, as a software developer, when you're new on the job, and that is seek independence, but also know when to put up your hand. So kind of the 2 sides of this coin that we're going to look at this issue through are, first, we really want to be independent as much as possible. We want to save the time of other people on our team, because as soon as we start to ask tons of questions that we could be solving on our own, we're also dragging somebody with more seniority and ostensibly more output in their code, or faster output of code, down into whatever is going on in our situation. It's slowing the team down, it's slowing us down, and it's making us seem less independent and less ready for promotion down the road. So shooting for independence is really important. On the other side, we also don't want to be so independent that we aren't asking for help and we're blowing a ton of our own time on a problem that could take a senior dev like half an hour to solve for us. And so this is this tricky trade-off. And so a couple things that you can do to help navigate that situation are, first, when you first land on a job, establish what tools there are. Ask tons of questions during your onboarding process of like, what internal documentation sites are there? Is there a quick way to find lists of documentation? Is there an internal Confluence or forum set that I can access that or search through in order to find solutions other people have used? I work for a very large organization, and so I search Confluence constantly. Confluence is my best friend. I find so many different solutions or directions to documentations or APIs that are internal that I would never have known existed had it not been for Confluence pages different people have typed up. So if you have those kinds of internal resources, learn how to use them, become a power user right away. Be the best person on your team at looking up something in the internal Confluence or the internal Stack Overflow or whatever that's going to look like. The next thing that you can also do that can be really helpful with this is get an idea of what the rest of your team's T-skills are. So T-skills are the idea that most of us have an area of technical depth and then some superficial level of knowledge about a lot of other things. Get an idea of who is best at what on your team, because the thing is you want to be asking a question relevant to the domain of the person you're asking it to. That's going to save you a lot of time. It doesn't help you anything if you're more comfortable with somebody that's really skilled with front-end stuff, but you've got a back-end specific question. If you go to the front-end person, they're probably not going to be able to solve it, and they might even get dragged into the conversation with the back-end person you should have asked in the first place. And so now you've tied up 2, 3, 4 people's time into solving this one problem versus just going straight to the source and establishing the relationship with the people that have the different areas of domain expertise. The last piece too here is knowing when to put up your hand. So for me, my rough rule of thumb, and this is going to be different for every person and every team, is if I'm halfway through the time I have allocated for a piece of code or a project or a feature or whatever it is, and I am not halfway done, it is time for me to put up my hand and ask for help, see if anybody else has got any ideas about how to solve a problem, how to get me unstuck, how to work through different things. And that saves me a lot of time because it doesn't get to the point where I'm playing tons and tons of catch up, and depending on the project, if it's a very long project, then maybe that's a quarter of the way through. You do need to use your best judgment in this rule. But for me, I work on a lot of short-ish, like 4 to 6 week projects doing prototyping work. And so for me, if I've got a major feature and I'm 3 weeks in and I'm only 2 equivalent weeks through the problem because I got stuck on something, that's when I'm going to ask for help, see if we can lop a chunk of that feature off and hand it off to somebody else, see if we can delay the timeline on it a little bit, but essentially just let people know that I'm behind so they can plan accordingly. Because the worst thing you can do is tell no one that you are behind on something until you're like 80% of the way done with the time you have allocated for a project and you only have 40% of it done. That is way harder to catch up from than if you only have 30% done half of the way through the project. That gives you more time. People can allocate resources differently. They can put you on a different story. They can do a lot of different things, but only if you put up your hand and ask for help. So this is kind of what runs contrary to the independence argument, is the idea that we do also, though, need to be able to ask for help. Just being independent and just spinning our gears and spending 2 weeks solving a bug that would have taken somebody else an hour is not a good use of your time as well as anyone else's time. So know when to ask for help, ask people quickly, and again, target the person with domain expertise in that area. Give them a heads up ahead of time, or reach out to your manager ahead of time. Be like, hey, I'm a little behind. Do you know who I should ask who's got extra capacity to try and deal with this issue? And they should be able to help you out as well. So that's just kind of a good thing to keep an eye on, is those two balances. Independence is kind of what gets you promoted, but also failure to ask for help will block you from ever getting promoted. That is one of those disqualification things. You don't necessarily get extra points for it, but you do need to know it, because otherwise you're just going to blow way too much time. It's going to slow you down, and you're not going to learn as much as you would have otherwise either. So folks, that has been 5 skills and learnings that I've taken out of my first 2 years in the engineering world. I hope it helps you. If you've got anything else that you want to add for the community, go ahead and drop it in the comments. I'll get to it as quickly as I can. And yeah, I'll see y'all soon.